Hello everyone. This video is intended to help you with problems that involve the coefficient of friction. We've dealt with friction before, but it was just a force, but now we're dealing with friction as a coefficient. And truth be told, this is the second time I'm doing this video. I did it outside before, not that you care. And when I played it back, all I heard was crickets and cicadas and birds and this rooster that lives 2 houses down and doesn't shut up. Not that you need to know this, but I'm telling you. Anyway, back to the point. This is basically an object being pushed across the surface, and it goes from rest, and it increases speed over a distance, and we're looking for the coefficient of friction between the object and the ground. Simple as that. By now, you should be experts in a problem-solving strategy, which starts with, as always, drawing a free body diagram. So we have a 300 Newton force acting at 20 degrees. We have a friction force, which I'm going to label FF, as we've done in the past. We've got a normal force because you know what? This thing is sitting on a surface, and we've got gravity because, yeah, we're near the surface of our planet, and there's a good amount of gravity. Otherwise, we'd be floating away. All right, anyway. Not much difference with the steps. We've drawn an FBD. Your next step is to sum the forces in the x that cause the mass to accelerate in the x-axis. If I look at my free body diagram, I have 300 newtons acting at an angle of 20 degrees, so cosine 20. And here's where it gets a little different. The expression for friction is the force of friction equals mu, the coefficient of friction, times the normal force. By this point in the year, I'm guessing most of you, instead of writing Fg when you sum the forces in the y, you're just writing mg. Well, same thing here. If you don't write friction, write mu times the normal. Replace friction with mu Fn. We don't know mu, and we don't know Fn. If we did know what mu was, then you would substitute in for mu. And the more you say mu, the weirder it sounds. It's all the forces in the x that's going to cause this 50 kilogram mass to accelerate in the x. At the moment, we have nothing that we can do here in the x-axis. Not to worry, though. You know why? Because by now, you're professionals. You know what to do. Let's do a little sum the forces that cause the mass to accelerate in the y-axis. However, this is a crate sliding across a floor. Odds are it's not accelerating vertically unless we make this challenging and put this object in an elevator that's accelerating vertically while the object slides across the floor. We won't go there. So we'll do a little Fn is up 300 newtons acting at an angle of 20 degrees. And gravity, which is negative mg, the mass I believe is 50 kilograms times 9.8 meters per second squared. And hey, we can get the normal force. Oops, that equals 0 newtons. So the normal force is equal to 387 newtons. Yippee. That's great because we now know the normal and we could sub it in. I want to stress this. Your job in these problems is to isolate the normal force and sub it into mu Fn. Okay, that is your goal whenever we have these kind of problems. Just isolate Fn, sub it in. I'm going to explain this a little bit more in detail later. But at the moment, we can't solve for the coefficient of friction. You know why? Because we don't know acceleration. But I know you're not worried because by now, you're experts. And you know that we still have to do a little kinematics. So let's get after it. For the kinematics part, we've got initial velocity, final velocity, acceleration. How many times will I write this in my career? Distance, time. Starts from rest. Achieves a speed of 2 meters per second after traveling a distance of 3 meters. We are looking for this acceleration to sub into the forces in the x. I believe this will be math rep number 4, where you have the final velocity squared is equal to the initial velocity squared, which happens to be 0, plus twice the acceleration times the distance. So subbing in some numbers here, twice the acceleration times the distance, we get an acceleration of 0.667 meters per second squared, or 666 if you're into that, you know, craziness. Just kidding. All right, let's sub that puppy back in way up here. There we go. And while I don't want to do this, I'm going to do it. 300 newtons, cosine 20 degrees, minus mu times the normal, which we found to be 387 newtons, equals 50 kilograms, times the acceleration, which we found to be 0.667 meters per second squared, and we get a coefficient of friction of 0.642, which is reasonable. Most of our coefficients will be less than 1. It's rare that we have a problem where the coefficient of friction is greater than 1, and we discussed this in class as to why. All right, so that's it. I mean, it's basically the same thing you've been doing, except instead of writing friction, you write mu Fn. So let's recap this puppy. As I scroll. Okay, this will not be edited. Basically, the same procedure is in place. You know, it's a dynamics problem. You do this free body diagram, forces X, forces Y, and kinematics. By now, some of you may be more seasoned professionals where you look and you're like, oh, I already have like starts from rest, a speed, and a distance. I can get acceleration if I start with kinematics. That's fine. I mean, I'd still start with the FBD, but I'm presenting this the same way every time. FBD, X, Y, kinematics. So there is a systematic approach. But if you see that it's better to start somewhere else because you can get the normal force or something else, then do that. It's all good. So the problems before this, we've been asked to solve for the force of friction, which we left as FF. But if you see coefficient of friction from now on, you should replace friction with mu Fn immediately. It's like instead of writing FG, we write mg. So instead of writing FF, write mu Fn. Now your job is to isolate Fn and to sub into mu Fn. Granted, there are times where there might be an easier thing to get to the answer quicker, and I don't want to go into too much detail about that, but if you see it, great. If not, just follow this procedure and you'll be okay. And sometimes, as an example here, you may get a normal force that's not a number. You may get something like Fn equals 300 plus 10x. I'm making that up. You will take that 300 plus 10x and sub it in for mu Fn. You'll sub it in right there for Fn. It's okay. It'll work out. Just isolate Fn and sub in. And refresh on the mu k, because sometimes problems give you both. Coefficient of kinetic friction is if you're slipping on the surface. So you might see the words like skid, slide, slip. Apparently a word that starts with the letter S. I don't know why. Static friction is not slipping relative to the surface. So the two surfaces are stuck together, stationary relative to each other. And actually an example of that would be rolling. When something's rolling, yes, the object is moving, which is irrelevant. The surface of the tire, for example, on your car is not slipping on the surface. If it was, driving would not be fun. You'd be slipping and sliding. Also, walking is a form of static friction. Yes, your body is in motion. Nobody cares about that. What we care about is the interaction of the two surfaces. Your feet are not slipping on the surface. Therefore, walking is static friction. Perhaps I just blew your mind. And because of that, I am going to give this video a rating of, yeah, definitely 3 out of 5 stars. I'm not changing a thing.